Hey guys, welcome again to my channel. Today I want to show you an exciting app that I've been working on for quite some days. I built it using Nestjs. So this app is a Forex Fintech application, an application that allows you buy and trade Forex. I built it using the Microservices architecture. This was an attempt to flex my muscles in building microservices using Nestjs. I wanted to see if it was indeed possible to build a microservice using the good old JavaScript and TypeScript. Guess what? It was possible, and I'm going to show you how I did it. The application I built was built with the following tools: Nestjs as the backend framework. I used gRPC for inter-service communication. Postgres, the trusted Postgres, was used as my database, and I used TypeORM for my ORM. For notification, I used RabbitMQ to queue up all the messages sent from the transaction service. You know how it is. And then I also used Redis for caching. The process we're going to follow today, rather than doing a step-by-step deep dive into how I build the application from scratch, I'm going to be, for the sake of time, walking you through over the finished product. I'm going to demo the application, hit a few endpoints to show you how it works, and then I'm going to dive into the code base and show you some important parts that I think might be beneficial to you. Nx monorepo is the crucial ingredient when you're building microservices using Nestjs, because it allows you to have all your microservices in a single repository, and then you get to share files like ESLint configurations, just configurations, and in fact libraries like code across all your applications, so thereby keeping your repository dry. You get to write once and use everywhere, and also improving your productivity. The format I'll be using for this video is, rather than going step by step and showing you how I built up the application from ground up, I would show you the finished product. And that's in two phases. The first phase would be demoing the application, and the second phase will be diving into the code base and zooming in on some key parts of the code that I think would be beneficial to you, especially if you're an intermediate Nestjs developer who is curious to see how to build microservices using Nestjs. I want to have you know that I would attach the link to the GitHub down in the description so you can follow along and compare and just browse through the code once you're done watching this video. And also, you'll be very glad to know that this app is Dockerized, so you will not need to install any other dependency. Now, just one more intro before we get into it. Here is the website for Nx monorepo. In case you're wondering, you can find it at nx.dev. Then for Nestjs, this is the website. And then you are also going to need one more thing, and that is an API key for the exchange rate API. This API, this third-party API, powers the exchange rate that we're using. So all you need to do is just add your email address and just click on this button that says Get Free Key, and you'll be sent the API key to your email address. Right. So this is the application. As you can see, this is the folder structure of a typical Nx monorepo. We have the application folder that contains the various microservices, auth integration down to web. And then we have the libs folder that contains libraries that are shared across this. In terms of architecture, this is what we have. The auth service uses Nestjs, obviously, uses gRPC for communication, and Postgres. The wallet service also uses the same technology. Transaction service uses, in addition to these two, Redis and RabbitMQ. It uses Redis for queuing up failed transaction and retrying them with the help of boomq. And then RabbitMQ, it sends message to the notification service over RabbitMQ such that notification service can now propagate the email to the user. Integration service uses Nestjs and gRPC and Redis. It uses Redis to cache the response from the exchange rate API such that the response is readily available whenever either wallet service or the user service needs it without having to make an extra call to the exchange rate API. By caching it, I decrease latency in the system and also save on the cost of making multiple API calls. With that being said, let's go to the architectural diagram. So we have 5 microservices in total, but 2 out of the 5 serve as hybrid services. And what this means is that they can receive HTTP requests from a client. And as such, these 2, the auth service and the transaction service, have exposed Swagger documentation. Now, let's go into installation. All you need to have as a prerequisite is pnpm and Docker with Docker Compose setup. And if you have that, go ahead and run the first command, that is to pnpm install. I've already done that, so I wouldn't be doing that. The next thing is, I'm assuming that you have gone to the exchange rate API key here and you have gotten your free API key. So what you have to do is open this apps and go to integration, create a docker.m file, and copy and paste your exchange rate API key in the following format. The next thing you have to do is to start up the backend service by running docker compose profile backend service up. Now let me explain what the backend services are. Like I mentioned earlier, when you go to the Docker Compose, you'll find out that we're using a couple of services like Postgres, Redis, and RabbitMQ, and then Mailhug. I'm sure by this point you're all familiar with these 3, but let me explain what Mailhug does. Mailhug is an email client that lets you receive emails while developing on your local host. So what this means is that every email sent by this application will be trapped in Mailhug, so you can preview it as though they were an actual email sent. And so when you run the Docker Compose profile backend services up, you have started all those backend services, and we can confirm they're all started by looking at the Docker tab here. You can see Mailhug, Postgres, RabbitMQ, and Redis. The next part is to run migration. As I mentioned earlier in this video, I am using TypeORM for my ORM, and TypeORM provides a way for you to generate migrations and run migration to get your database up in sync with the models that you have created. I wouldn't be showing you how I generated the migration, but suffice to know that you have the migration file once you have pulled this repository. So all you need to do is to copy this command and run the migration. One thing for full disclosure is running the migration does not create the database, and you might be wondering how I'm able to run the migration if I have not gone ahead to create the database. And the secret is this. So in the Docker Compose, when you go to the Postgres service definition, where is it? It's up here. You can see that I have the volume mapping to a special file. That is docker entry point init.d. And I have this docker init.d mapped here. So when you go to your application at the root repository, you will find the folder called docker and then init.sql. So this is responsible for creating all the various databases that you will need for this application. So whenever you start up your Postgres container, it runs this command and creates this database if they are not already created. And so by the time you run Docker Compose profile backend services up, you have started in addition to all the other backend services Postgres, and Postgres has taken the liberty to create the various databases you need for this application. So when you run this pnpm migration run, the various databases, the wallet auth and transaction database could be found. And just to confirm, let's look at this. So I've already created a connection to the database server, and let's review the database is created. You can see we have the auth, the transaction, and the wallet database. And when you look into it, you can see among the various tables we have in the auth, we have the users table. In the transaction, we have the Forex order and Forex transaction table. And then in the wallet, we just have the wallet and wallet transactions table. And this is all you need to have set up the system. And then the final part is to actually run the APIs, the microservices, and that you can do by executing this command. Running this command will start up the microservices, and let's check that it's all started up. You can see we have the auth integration, notification, and transaction. I mentioned earlier that the auth service and the transaction service are hybrid services. So what this means is that I have gone ahead and exposed the Swagger documentation for these services. So you can find the Swagger documentation for the auth service, which we'll be examining first by going to localhost 3000/swagger. And I'm going to zoom in here. So when you go here, you find out that I've exposed 5 endpoints. The 2 endpoints are for authentication, that is sign up and login. And the other endpoints are to query user wallet, to create user wallet, to get all the user wallet, and to view supported currencies. So let's go ahead and sign up to create a new user. I am using class validator here, so it's very important that you try to create a strong password. If not, the API endpoint will not validate your entry. So I'm going to create an email. And then I'm going to choose a very strong password. And hit execute. You can see here that we have gone ahead and logged in. When you log in here, I've also made it that logging in would also sign you up. How does the sign up work? The sign up uses JWT authentication, and the JWT token is generated and attached to a cookie. This cookie is HTTP only cookie for more security. If this is the recommended way to store your JWT token, rather than storing it in local storage or any other cookie form, it is recommended to use HTTP only cookie. With that, by doing that, you are going to be immune to cross-site attacks, because when the cookie comes to the browser, it's only the browser that can send the cookie back. No other rogue JavaScript can intercept this cookie and use it. And to confirm that this cookie is set, we can inspect here and go to storage. And then when you look at here, you can see that the JWT cookie is set. And when you also look at here, you see that it's a HTTP only cookie. By setting this cookie, we are able to go ahead and access other endpoints that are already protected. So the first thing we want to do for this user is to create a wallet for a currency. So I'm in Nigeria, and my local currency is Naira, which is denoted by the ISO currency code NGN. So I'm going to write NGN here. And just to be sure, let's verify that this NGN currency is supported by this API. And I'm going to hit this endpoint, and it returns a list of supported currencies in alphabetical order. So you can see that when we go to the section that has N, here is a Naira is supported. So we're safe. You can go ahead and hit this endpoint. So if you were to choose an endpoint, maybe a currency that is not supported, we'll just do AAB and hit it. I have a class validator DTO set up that to ensure that the currencies are validated. So there are 2 checks for currency validation. The native class validator decorator that validates that the currency code is of this format, and also I have a class validation rule that makes a call to the integration service to check if this currency is among the supported currencies. So in that way, you're very sure that no one can create a currency that is not supported by the system. Alright, so we have created a Naira wallet. We can go ahead and try out this endpoint to get all the wallets. And you can see we have the Naira currency wallet and the balance is 0.0. And I think with that, we have completed all the endpoints in the auth and user service. I'm going to go ahead and copy this wallet ID because we're going to need it when we go to the transaction service. The transaction service Swagger can be found by going to localhost 3001/Swagger. So here you can see we also have, like the other one, 5 endpoint exposed. We have the buy Forex endpoint, which is used to purchase Forex from a base currency to a target currency. We have the transactions fund wallets endpoint, which is used to fund the wallet by passing the wallet ID. We also have the withdraw from the wallet. And then we have these 2 endpoints for fetching all the orders that have been made. Whenever you attempt to buy Forex, a new order is created and a new Forex transaction is also created. So before we buy the Forex, let's go ahead and fund our newly created wallet. I'm going to paste in the wallet ID I copied from the previous step into here. And then I'm going to fund my wallet with 500,000 Naira. It's good to be rich, you know. And so go ahead and hit it. And you can see that we have 500,000 Naira as a balance here. If you go here and query for all the user wallets, you will see that we have 500,000 Naira reflected here as well. So let's go back to the transaction service Swagger and continue. Next thing I want to do is to buy Forex in US dollars. There were 2 possibilities when I wanted to support this feature. The first possibility was to ensure that a user must have initially created the target wallet before they could purchase Forex. The second possibility was to just validate that a user must have a base wallet, and then if they try to buy Forex in a wallet that doesn't exist, the system will go ahead and create the wallet for them before buying the Forex. I decided to go for the latter approach because I felt it offered the best user experience to allow users to dynamically create wallet by issuing a Forex request, a buy Forex request. And that's what's going to happen here. If you go back, you can verify that we do not have any other wallet here. But by the time when I buy a Forex in USD, you'll find out that in addition to having the currency bought, we would have created a USD wallet. So right now, my base wallet is obviously going to be NGN because that's the only wallet I have. The target is going to be USD. And then the amount, let's just decide to buy 2,000 Naira worth of USD. And when we hit enter, the order was successful. You can see we have the Forex order ID and Forex transaction ID. And then I want to segue to this. Remember how I talked about MailHug being one of the services I had started here, and MailHug is supposed to be the email client that you would use in your local host. So how do we access the MailHug? So when you refer to the Docker Compose, you will see that in the MailHug we have 2 ports exposed, the 1025 and 8025. The 1025 is the SMT port that the email node mailer uses, and then the 8025 is the port that you can use to view the email client. So if we were to go to localhost 8025 here, you would see the email client. And what do you know? All the previous transactions we have performed have an associated notification. For the first time, when I funded the wallet with 500,000 Naira, you can see I have an email to that effect. And then when I purchased the Forex for USD, it tells me that, oh, your USD was credited with 0. This is an error, and an exchange rate of $1 equals to this. This error is happening because I am trying to use to string in a decimal, which I'm going to get to later.
but for now, I would fix this error in the future. Don't worry about it. The point here is that our mail hog is working as expected and trapping the emails that are being sent. All right, back to it. So when we go here and try to query for the Forex orders that we have created, and we try this out, you can see we have one entry in the table, and this entry documents the various Forex order we have made. So we've initiated a buy order from a base currency of Naira to USD, and an amount of 2,000 is completed. When we go to the final endpoint and hit it, we get more information. This Forex transaction is like a mashup of both the request object and the response. And so when you hit execute, you get to see that in addition to the base currency and target currency, you also get to see the exchange rate and the target amount that was purchased. So if we were to go over to the user and auth service and make a request to fetch all the user wallet, you'll find out that we have 1.25 USD, and also the Naira has decreased by the 2,000 by the equivalent USD amount in Naira. All right, I think with that, that's the whole run through of the whole application. And then let's segue into the code to show you some key parts of the code that I think you might find interesting. Now, I would want to draw your attention to the organization of the libraries. So to support this application, to make the code dry, I've grouped a couple of items that we have reused across the microservices into libraries. I have a special library for gLPC. I have another library that groups the microservice clients together. So you need, for a microservice to communicate to another microservice, for instance, for transaction to communicate to us, it has to get hold of the auth client. And when it gets hold of the auth client, it needs to inject it as a dependency into the service before it can make the request. So one way to go about that is to just follow the Nestjs recommendation for microservice. And you can check that out by going to documentation, microservice, and then when you go to microservice, quick overview, and then go to the clients. So for example, let's say you're using RabbitMQ gLPC like we're using, you would have to create a client by creating a client config like this and importing it into the module. But the very fact that in this microservices there is cross communication between one service and various other services, it would be a bit repetitive to have to define and import these clients every single time we want to get access to a client. So I decided to bundle the whole microservice client into a module and export that module. So as you can see here, I have a microservice client module which is responsible for aggregating all the microservice clients. One more thing I'm making use of is an advanced concept in Nest.js called dynamic module. So if we refer to the README, you can find out that, for example, the transaction service makes a request to wallet auth integration and notification service, whereas the wallet service only makes a request to integration service. If I weren't using a dynamic module, it means that I would have to register all the various clients in this module here, in the imports of this module. But that wouldn't be what we want, because, for example, a service that does not depend on all the clients will now have to depend on them. We'll be forcing it to depend on it. But with a dynamic module, you can configure your modules by specifying in some input and only get the input that you desire. So in this microservice client module that I've created, the configuration you need to pass in is just of this following interface. So you have to pass in an object that has a key client that is an array that is mapped to an array value, and then the array can be one of these strings, either auth, wallet, notification, or integration. So just for example, I would show you the users module and show you how this microservice client is implemented. So in the users module, you can find out that you can see that the microservice client module is implemented by calling the register function, and then we are passing in config of just wallet and integration. And what this means is that this users module would always import clients of wallet and integration. So with this done, we can go into the user service, and you can see in this constructor we are injecting the wallet client and integration client as dependencies here. And just for comprehensiveness, let me also refer you to the wallet module, which makes use of the integration client. So in the wallet module, you can see that we already have the integration client being defined here using the microservice client module. And then when you go to the wallet service here, you can see that we're also injecting this as a dependency here. And so that's one cool trick I use to make my code dry and make it more maintainable. Then like I had promised, I wanted to show you the secret behind building a sustainable and accurate fintech application using TypeScript and JavaScript. And that secret is using Nestjs. As long as you do all your computation and mathematical calculations using Nestjs, you will not be prone to the roundoff error that is prominent in JavaScript numerical computations. So I'm going to refer you to the wallet service and show you the logic behind buying the Forex. So when we go to the wallet service and search for buy Forex function, you can see it's a bit involved. So the first thing we do here is to fetch the exchange rate, and this exchange rate returns a promise of a decimal, and this decimal is an instance of the Nestjs library. So this exchange rate is a decimal. The next thing we do is to try to verify that we have at least the base wallet and try to see if we can find any target wallet. If we cannot find the base wallet, we return an error, of course. And then here is an example of performing computations using the decimal library. So right now we're getting the request amount and converting into a decimal. And then the next thing we're doing is we're computing the target wallet amount by multiplying the exchange rate, which is a decimal, with this amount. So this is how you perform multiplication using Nestjs. The result of this computation is also going to be a decimal. And so you can see that all through here, we are just using decimal. So what this means is that at the end of the day, we are doing our computations in decimal, and we are not prone to the roundoff error that is prominent with the number system in JavaScript. And the final thing to note is when you want to transfer your currencies over the wire, it's very recommended to send them as string. So because we are using gRPC, I want to refer you to the gRPC proto file for the wallet service, which can be found by searching for wallet.proto. And so when we go to the buy Forex request, you can see the amount is depicted as a string, and in the response, the amount is also a string. So in a nutshell, send your request and response as strings. When you get them as strings, use the Nestjs library to convert them to decimal. And as long as you do all these things, you'll be good to go. All right, I think with all this, we have gotten to the end of this expose and walkthrough.
So if you made it this far into the video, I thank you for your support. Just as a reminder, I will be attaching the link to the GitHub down in the description so you can check out the code and just browse through it and learn. And so if any questions come up, please feel free to ask them here in the comment section. If you have any suggestions or opinion that you would like to discuss with I or others, don't hesitate to put it down in the comment section. And if you found this video valuable, please click a like